All right, guys, am I done? The question is to determine the velocity of point B, of point D. So what should I do, Abbas? I need the direction. Perfect. So this is only the magnitude. Now, if I applied the equation of relative velocity, I can find the direction of VD directly, right? Because I know VD in I and J. Now here, since I am using IC, I have to find the direction after finding the magnitude of VD. How to find this direction? I know, in fact, that this will be VD. So let's change the color. This will be VD. It will be perpendicular to ICD, okay? And it will be in this direction since omega is counterclockwise, all right? So this is 90. In order to find the direction, I have to find an angle with a certain fixed axis, like for example, x-axis. So if I know the angle between VD and x-axis, which is this one, and I'm gonna call this angle, let's say alpha. If I know this angle, I can indicate the direction of VD. Now, how to know this angle? In fact, this angle is 90 minus this angle, which is phi, minus this angle, which is 30. All right? So in order to know alpha, I need to find phi. How to find phi, guys? How to find phi? From phi. Guys, as I said, if I want to apply IC, I have to put on my mind that I need the cosine and sine rule. I might need them. Right, so here I need the sine rule in order to find phi. Yes, but in fact, I can use 30 over ICD is equal to sine phi over 0.50. All right, so sine 30 over ICD, which is 0.18. Five is equal to sine phi over 0.15. So now I can find phi. Phi is in fact equal to 23.79. And then I can find alpha. Is 90 minus 30 minus 23. And alpha will be equal to 36.2. Now that I know alpha, guys, I know the direction of VD. So what I can say that VD in vector form will be equal to minus 5.72 cosine 36.2 I plus 5.72 sine 36.2 J. Right? So now your answer is considered correct. Or what you can do also, if you don't want to express VD in a Cartesian reference, what you can do, you can say also like this. VD is equal to 5.72, and then you can draw this VD like this, guys, and indicate this angle as 36.2. So this is also a correct answer, right? Because if I know that VD is directed in this direction with this angle with XX prime, then I can find the direction of VD. Any question on this example? Question, guys? Oh, because Batu, this is a non-deformable square plate. This is a rigid body. It's not a crankshaft, or it's not for example, some beams that are connected with pins. No, this is a square plate. I'm gonna always have this 90 degrees for any instant. So this is a rigid body that is rotating like a disk. All right, so you cannot say that BD has different omega than BC. They are not connected links. All right, I have one square plate. like a disk that is rotating with a certain omega. Okay, Batul? How do we know when to use vectors to solve the question and when to use scalars? Abbas, it's up to you. You can solve this problem using the vector equations, but here I am applying the knowledge for instantaneous center of zero velocity. All right. So if I ask you to apply the instantaneous center of zero velocity, you have to use this method. If not, you can choose between them. Okay, Abbas, you can use the vector equation and you're gonna have the same answer. Try it. Okay.